Hey everybody. Hey, want you to see my Mount Lassen National Volcanic National Park shirt I got on today? We're going to talk a little bit about volcanoes and specifically lava and magma. Lava and magma. Magma is in the earth. Lava is when it comes out. And as you know, that creates igneous rock. Now, I've got 3 glasses of different fluids, and we're going to pretend they're lava. And here's why this is important. There's this thing called viscosity, or viscous. Now, fluid is viscous if it's thick. If it's very viscous, it's very thick. Now, maybe you can guess which one of these is the thickest. But I'm going to show you what happens with thick lava. Thick lava traps in gases, and so it's more explosive. Thin lava doesn't trap gases, and it runs quickly. Now, that's important for 2 reasons, and we're going to talk about those in just a moment. Now, here we have our thin lava, kind of medium, and thick. Now watch what happens when I blow a little gas into the lava. And I'm just going to blow through my straw here, my straw of lava science, and I'm going to blow a little carbon dioxide, just a little breath of air. And we're going to watch the bubbles. So, okay, watch what happens and see if you can see how fast the bubbles move through this fluid block. Okay, that's pretty obvious, right? You could do this at home. One more time. Just kind of one breath. You can see they escape very quickly. It doesn't stay in there. I'm going to move my straw of lava science over here to this fluid. It's pancake syrup. Watch this one. You see it okay? Let me move these back a little bit. Here we go. Okay, so you can see it's much more sticky, kind of traps the gas. You can even see there's some bubbles still trapped, whereas with this, of course, there's no bubbles trapped at all. Okay, and then we're going to go to our thickest lava. And this, of course, is honey. Shh. It's really sweet. Honey. You might notice the hearts on the wall behind me, the glass, because it's sweet. Honey. Here we go. And I don't know if you even noticed how much harder it is for me to blow the air into it. Watch this. Okay, pretty cool. So this one, this is so sweet. So this is honey, and you can see it really traps the gases. And then we've got a little thinner, which is syrup, and then we got the thinnest, which is the water. Now, which of these is going to be more explosive in lava world? Well, the one that holds the gas, explosive gases, it's going to act like a bomb, and pow! And that's what we see in volcanoes like Mount Lassen, when it blew in 1915, or volcanoes all over the world that are more explosive, Mount St. Helens from the 80s, but volcanoes on the subducting plates and the Pacific Ring of Fire. Now, Hawaii. Now that's important because the next video you're going to watch has to do with Hawaii. Now those volcanoes have runny lava, and runny lava doesn't hold the gas, so it's not explosive and it moves very quickly. Okay, so this is very viscous, this is non-viscous. Now, here's the key. The Hawaiian Islands are built on basaltic lava mainly. It flows easily, does not trap gases, is not explosive. In fact, Kilauea still erupts frequently all the time, and it doesn't cause any real danger explosivity-wise. Volcanoes, though, that explode have that trapped gas, and that's granitic lava. And basically, one key word, as you'll learn about this, is silica content. So the more silica, the more viscous, the thicker, and the less silica, the runnier they become, and less explosive. So there's our little lava of science, magma, sweet little lesson. You get why I said sweet, because yeah, never mind. And now, to go to Hawaii. We're off to Hawaii next. Bye-bye. Hey everybody, hope you can hear me okay. Mr. P here with my daughters Heather and Hannah. Heather was in my class last year in 09, and Hannah's coming up, 5th grader, this year. So hey, we're out in a volcanic wilderness for our summer vacation here in Hawaii and Maui, and I thought I wanted to do a little video to teach you about this stuff, okay? So first, we're out in this crater, this caldera. We're going to learn about calderas, big bowl that a volcano creates, holds water usually. In this case, this caldera is out in the ocean, Pacific Ocean. Over there, we're going to pan over, and you're going to see the top Haleakala, and it's a big shield volcano. Okay, basaltic lava, not real explosive, but this is dormant now, it's quiet. And this is an older island than the big island of Hawaii, which still has active volcanoes. If you pan left, we're going to see the valley. It's called the Valley Island. Maui is. And you can see it created a valley between two volcanic peaks. And over here, and this is the north side of the island, that way. And over here, we're on the south side of the distance. Okay, and that's west. We're going west that way. Our hotel's on that shoreline over there. We're on a boat called the Quicksilver, and we're out at the Moakini crater out in the middle of the ocean to go snorkeling. And so, now here's the difference between Hawaii and Mount Lassen, okay? So we're going to hike on Mount Lassen. Mount Lassen, because we're in California, so picture, here's California, and here's the Pacific Ocean, got it? The Pacific Ocean plate tectonics, eggshell of the Earth, goes underneath the North American plate right here, the Gorda plate, and up here in the northwest, and it creates the Cascade Mountain Range, and Mount Lassen's the southernmost volcano. So those volcanoes are granitic lava, they're very explosive. So we have this big mountain peak, so Lassen, Shasta, Crater Lake, which is also a caldera. We have Mount Hood, Baker, all those on the Cascade. So that plate is subducting, the Pacific plate is subducting under the North American plate. Okay, and it lets the magma rise up there at that seam. Seemingly so. Okay, then over here though, this is called hotspot volcanoes. These volcanoes are not at a plate boundary. So here's back at the Pacific. So here's California, here's the Pacific plate. But out here, out in the Pacific Ocean is where the Hawaiian Islands are. And this plate is moving northward, and as it does it, it pushes those little plates in there. But over here it's moving, and what's happened, a hot spot, it's a thin area of the crust where the magma rises up. So right now in Hawaii, the big island of Hawaii, the southernmost island, is still erupting lava. This one's quieted down now because it's north and older. And so the Pacific plate moves over the hot spot and lets the volcanic magma, that sweet spot, rise up. But not explosively. It's not because they're not plates crashing into each other. It's just moving gently. Okay, so there's our little plate tectonics lesson. We're going to learn way more about it, and we're going to hike on a volcano, but we're not hiking on these volcanoes because these are hot spot out in the Pacific Ocean. But if you ever go, or if you've been, a little lesson how these differ than our volcanic wilderness that we live in. Okay? There's our little plate tectonic lesson from my vacation, my family's vacation here in the Pacific Ocean. And we're going to go snorkeling. If you see these people snorkeling out here, we're in a caldera. It's got a coral reef and tons of fish. And we're going to go out and snorkel for a while and have a blast. There you go. Thanks for watching. Bye from Hawaii.
Adios.
And Maui. See it? You recording? Don't back up anymore. I don't want my photographer getting hurt. Alright guys, hey, so last time I had on video, I was in Hawaii, and I was on a hotspot volcano. So remember, hotspots are like a thin part of crust where magma kind of squirts up through. Here at Mount Lassen National Park, Volcanic Wilderness, it's not a hotspot volcano, it's different. We're at plate boundaries. So imagine, again, that, I think I talked about it before, we have a subducting plate out of the Pacific Ocean against the North American plate, okay? And that causes a ridge of volcanoes. Mount Lassen being the southernmost, the farthest below, all the cascades that go up around the Pacific Ring of Fire. But right now you can see we're at Bumpus Hell, hydrothermal area. You can see that rolling water, boiling, all the steam, because the magma chamber down below us here about 6 miles deep, below the crust of the Earth, is driving all that moisture and water that seeps down in there to boil up and out. And that's why we have all the steam. If you look over here, you can see all the boiling steam and fumaroles, those mud pots, and you see a bunch of our class down there in the bottom, and all the different colors because all the minerals of Earth are coming up and out. And so, this is not a hotspot. This is a plate boundary volcano that we know, lasting all the way up to, Crater Lake and Mount St. Helens and all the way up into Alaska, and versus the Hawaiian Islands that are those hotspot volcanoes that move in that Pacific plate. So that's how they differ. But here we are in a hydrothermal, geothermal area. Pretty outstanding. So I hope you remember Bumpus Hell, named after Kendall Bumpus, who burned his leg when he was giving tours in the late 1800s. So it's dangerous, but well worth coming and seeing it per se. So cool stuff. Hope you liked it. See you next time. Okay, everybody. So last we visited, we were at Bumpus Hell, talking about that plate tectonic action and those plate boundaries and those mountains. So now, my family and I are standing on top of Brokaw Mountain, which hopefully you've learned. This once was the edge of Mount Tehama. So imagine behind me, all the way to Mount Laspine, that's Mount Tehama. And then as you moved away, explosions and glaciation, etc., like that 9 years ago. Leading this is Brokaw here, and there's Mount Laspine. On this side of the mountain, you can see Vulcan's Eye on the right there, but coming off the top, you can see from the 1915 eruption a little bit of lava flow. Out behind here, you can see crags on the other side there. And then if we pan all the way over to our left, you'll see Mount Shasta. And of course, going north, and that's where we're looking right now, is the Cascade Mountain Range. So you can imagine Mount Hood in Oregon, and Crater Lake, and Mount St. Helens, and Mount Rainier, and so forth. So come back this way. And then, if ever you've been yet to Bumpus Hell, that's Lake Helen, and the parking lot, you can just see it there, and the mountain road going to it. Here we have Mount Diller, and then Pilot Pinnacle. If you can see it, it's the big jagged rock sticking down at the base. It looks like the base is lasting, but it's really not the base. And so, we did it today. It was a hard hike. It's 3.5 miles here, 7 miles round trip, and now we got to go downhill. Great hike. I highly recommend it. I'm going to bring my class here. It's a little dangerous. So, you can bring your family. Look out there, you can see Lake Almanor. And of course, the Sierra Nevada mountains heading in that direction. As hopefully you know, Lassen's the southern mountain of the Cascades. There's the Sierra Nevadas and down to Yosemite, or Yosemite, or whatever you want to call it. So, this place really rocks. You should come here. It rocks.
Rock.
Bye.
Bye.